Hello everyone, welcome to Simply Math, and in this video we're going to be covering rate conversion. So we're going to be starting off our whole overall new unit, which is going to be called Working with Units. And for this video, the first thing we're going to be covering is dimensional analysis. And I know that sounds like a really fancy name, but it's really not that hard of a concept. Let me show you with an example. Suppose you have 350 grams of feathers. So I'm going to call it, let me write the G for grams, FT H. And now I'm asking you, how many kilograms of feathers do we have, right? So, kg of FTH. So, how would I get from grams of feathers to kilograms of feathers? Well, I know that for every 1,000 grams, there's 1 kilogram. So, for 1,000 grams of feathers, there should be 1 kilogram of feather. So, let me write this as a fraction. 1 kilogram of feathers is equal to 1,000 grams of feathers. So let me just erase this and move it out the way a little bit. But now if I multiply these together and I cancel out the grams of feathers with the grams of feathers, my remaining answer is going to be in kilograms of feathers. So then I'll do 350 times 1 divided by 1,000 to get 0.35 kilograms of feathers. Now, over here in the middle, we use the fraction to get from 1,000 grams of feathers to 1 kilogram of feathers. This fraction is called a conversion factor. Now, all conversion factors are equal to 1 because we use conversion factors to get from what we started to what we ended with. And we want to keep it the same throughout, right? We don't want to change up the value midway through. So our conversion factors have to be equal to 1. So this right here, 1 kilogram of feathers is equal to 1,000 kilograms of feathers, is our conversion factor. And we canceled out grams to get to kilograms. So that was a pretty basic example. But now let's try with another one. This time we're going to do 180 kilometers per hour. And we're going to want to find meters per second. So, if you'll notice, we're going to have to change from kilometers to meters and from hours to seconds. So, we're going to need to use multiple conversion factors. First, let's use one to get from kilometers to meters. So, let me rewrite these fractions right here so that they're a little more suited for dimensional analysis. S hour. So, to get from kilometers to meters. Well, I know that in every 1 kilometer, there's 1,000 meters. So let me write that down. 1 kilometer is 1,000 meters. So here, kilometers and kilometers would cancel out. And so now I have meters per hour. But we want meters per second. So how would I get from hours to seconds? Well, I do know that in every 1 hour, there's 60 seconds. So let's do that then. I mean, not 6 seconds, sorry, 60 minutes. So 1 hour has 60 minutes. And in every 1 minute, I know that there is 60 seconds. And so hours would cancel out with hours, minutes would cancel out with minutes. And so now I'm going to erase the meters per second here so that I can have a little more space to show you the next step. What we're going to do is we're going to put all of our numerator terms together and all of our denominator terms together. But what you'll also see is this. Look, we have meters here with nothing else in the numerator, and seconds here with nothing else in our denominator. So let's write down m, extend the fraction bar, and say s. So we have 180 times 1,000. That's going to be 180,000. And then we have 60 times 60, which is going to be 3,600. So this is what our answer is, but we can definitely simplify this down, so let's do that. So the zeros cancel out, the second set of zeros cancel out, so you have 1,800 divided by 36. Well, 180 divided by 36 is 5, so 1,800 divided by 36 would be 50. So we're going to be left with 50 meters per second. So this is our answer, and 50 meters per second should be the same thing as 180 kilometers per hour. And that's all you have to do for dimensional analysis. Just use these conversion factors here to get from what you have to the quantity that you want. So let's try with another example, and this one's going to be a little more complicated than the other ones. So let's try with another example, and this one's going to be a little more complicated than the other ones. So let's say that you have an acceleration rate of 0.5 meters per second squared. And so first off, I know meters per second squared may seem a little confusing, but just think that the speed of whatever the object is, we don't know, is increasing by 0.5 meters per second each second. So its speed is going to be increasing by 0.5. So anyway, let's get to what we actually want. We want our answer to be in meters per minute squared. So we do know how to get from seconds to minutes, but how are we going to get from seconds squared to minutes squared? Well, we just square it. So we know that again, in 60 seconds, there's 1 minute. But this will cancel out this second power, and it'll cancel out this s. But you're going to have this weird thing where you're going to have seconds and minutes in your denominator. So you'll multiply again by 60 seconds per minute. And now this s will cancel out with this s. And so now seconds is totally gone from the denominator, but you have minutes times minutes, so you have minutes squared. And so you're going to be left with, if you notice, meters per minute squared. So now all we have to do is multiply. Well, 0.5 times 60 is 30. 30 times 60 is 1,800. So our final answer is going to be 1,800. I wrote it a little too far off. Meters per minute squared. And that's all for this video. Please make sure to like, share, subscribe, leave a comment down below, and follow us on TikTok at simplymath_. Thanks for watching.